If ax plus b is equal to 0, is x greater than 0? So if our question is asking us something about x, usually I would want to put my equation here in terms of x. It does not look like we can really do that here because we would have to divide by a to get x by itself. And in order to do that, we have to first make sure a is not equal to 0. And so I don't think I can really get my equation here in terms of x. And so there's not much to do here except look at our statements. I will, however, write out our equation. Statement 1 says a plus b is greater than 0. So since I couldn't get everything in terms of x, I might just test out numbers here. I just need to choose numbers for a and b such that a plus b is greater than 0. So I need an a, I need a b. Based on that, I need to calculate what my x is. And then I need to answer my question, is x greater than 0? And as always, my goal here is to prove insufficiency. So let's just choose a set of easy numbers where a plus b is greater than 0. I'll say a is 5, b is 3. So in this case, we have 5x plus 3 is equal to 0. So x is equal to negative 3/5. So in this case, we have an example where we have a no to our question. So now I should be trying to get a yes to our question. And let's see if I just make one of these negative. I have to make the 3 negative so that a plus b is still greater than 0. But then in this case, I have 5x minus 3 is equal to 0. And x is equal to positive 3/5. This gives me a yes. And that is good enough to prove insufficiency. Statement 2 says a minus b is greater than 0. And so the good news here about being organized with how we chose our numbers here is it looks like each of these values from statement 1 can be reused for statement 2. So that not only means I don't have to do any work when looking at statement 2, I can say it's insufficient, but I also do not have to look at my statements together because since both of these examples work for statements 1 and 2, I can reuse them without any new information being revealed, which means E is our answer.